And welcome back for our final session of the day, Smarter Work Zones. Before we begin, we just want to make sure that we get out a huge thanks to all the folks who have worked very hard to make this thing happen, starting with the great people over at TTI, with all of our great people at FHWA, and of course, all of my colleagues at ARTBA. Special thanks to Justin Russell, who's in the background. You don't even see him, but all of the things are happening, and they're happening well because of Justin. So thank you very much for everything there. So without further ado, let me go ahead and introduce you to our moderator for this session, Brad Sant. He's our Senior Vice President of Safety and Education here at the American Road and Transportation Builders Association. He oversees safety advocacy and training, including the National Work Zone Safety Information Clearinghouse. Some of you may have heard of that, and various federal safety contracts. Previously, Brad worked for the International Association of Firefighters and the National Association Building Trade Unions with the AFL-CIO. He's also served with the National Resource Center of OSHA Training and chairman of the board of Safety Equipment Institute, which is a division of ASTM. He graduated from Utah State University and earned a law degree from Georgetown University Law Center in Washington, D.C. Last but not least, Brad is a certified safety professional, so he is going to take us there. Go for it, Brad.
All right, thank you, Matt, and thank you to our presenters. We actually really do have a who's who of presenters here and talking about smarter work zones today. So I will introduce them and then get out of the way so you can hear from those experts. We'll begin with James McGinnis. He's with the Florida Department of Transportation. He's a professional engineer with a Master's of Engineering degree from Florida State University. He's been with FDOT since 2017. James is currently the lead plan reviewer for innovative intersections for FDOT. He's also responsible for the FDOT Temporary Traffic Control TTC standard plans. James was also part of the team that created the developmental standard plans for smart work zones and led the development of a new designer-based temporary traffic control training. He'll be followed by W.D. Baldwin, who is a Florida PE and a graduate of Iowa State University with 30 years of experience in planning, design, construction, and maintenance of engineering projects. His expertise in the transportation industry includes highway operations, focusing on work zones, traffic analysis, roadway safety analysis, connected vehicles, and intelligent transportation systems. WD is currently the GEC Consultant Project Manager for the team supporting FDOT's Connected Mobility and Technologies program. Since 2010, he has championed the improvement of work zone safety and mobility utilizing ITS technologies. And then following WD, another Iowa native, well, I don't know if he's a native, but he's from there right now. We have Dan Spreglinger. Yeah, sorry, Dan, who earned his bachelor's degree in civil engineering from Iowa State University in 1983. He has served as the work zone traffic control engineer for the Iowa Department of Transportation since 1993. He has been a work zone safety instructor for over 30 years. He currently serves on several NCHRP panels that deal with work zone safety. As an active member of ATSA. In June 2024, he joined the National Committee on Uniform Traffic Control Devices as part of the Part 6 Technical Committee. Mr. Spreglinger has been employed by the Iowa Department of Transportation since 1984 and is a registered professional engineer in the state of Iowa. Wrapping up today will be Neil Bourdreau. He serves as the Assistant Administrator for Traffic Safety for the Massachusetts Department of Transportation Highway Division and has been with MassDOT since 1995. We've got a lot of great veterans here. He's been serving in many roles with the Traffic Operations and Safety Management Group. In his current position, Nell represents MassDOT as a member of the National Committee on Safety and is currently serving as the Vice Chair of the Committee on Traffic Engineering. In addition, Neil is a member of the National Committee on Uniform Traffic Control Devices, serving as the Chair of the Temporary Traffic Control Technical Committee. So a great panel of experts to talk to us about smarter work zones, and we'll all be smarter as a result of being here today. So take it away, James.
Thank you, Brad, for that introduction. Hello, everyone. Today, WD and I are going to talk to you about what FDOT has done with smart work zones. To date, FDOT has developed guidance materials, developmental standards, and specifications for 4 smart work zone strategies. The smart work zone strategies are Work Zone Data Exchange, also known nationally as WZDX, Dynamic Queue Detection, Slow Speed Warning, or DQW, dynamic lane merge, or DLM, and dynamic speed harmonization, DSH. And except for WZDX, the Smart Work Zone strategy acronyms are primarily used only within FDOT. The strategies, technologies, and guidance materials are described in greater detail over the next few slides. All right. The first strategy is the WZDX. So the WZDX is a national program sponsored and promoted by the Federal Highway Administration. FHWA has developed the Work Zone Data Exchange specification to provide uniform guidance and instructions. The WZDX enables infrastructure owners and operators, like FDOT, to make Work Zone data available for third-party use. The goal of the WZDX is to enhance the ability of vehicles equipped with automated driving systems to safely and efficiently navigate work zones. FDOT is planning to transition towards the use of WZDX for projects on limited access or high-speed roadways with a level of service E or F, existing or anticipated during construction, with work zone traffic impacts lasting 5 days or more, and with a construction duration of 6 months or greater. The WZDX uses a roadside device that transmits its location and certain messages to the cloud using cellular internet. The WZDX devices are placed at roadwork ahead sign locations and are located on PCMS and aero boards. The messages the WZDX device transmits is based on its location. For example, a WZDX device located within an aero board will transmit a right or left lane closed message to the WZDX data exchange hosted by FHWA. The Smart Work Zone strategy nationally used is the Dynamic Queue Detection Slow Speed Warning. FDOT has abbreviated this strategy as the DQW. The DQW is deployed where lane closures, restrictions, or other construction activities may cause traffic to slow or stop. This causes queues to build upstream from the traffic restriction. The queues often result in stop and go or slow and go conditions and could potentially cause rear-end collisions. The strategy is used to alert motorists of the conditions ahead, giving them heightened awareness and time to slow down before coming upon the downstream congestion. The DQW uses Smart Work Zone vehicle detectors located in and ahead of the work zone to monitor traffic speeds and volumes. Then, algorithms developed for the speed of traffic and placement of the equipment are set to activate upstream Smart Work Zone PCMS messages to warn traffic of the condition ahead when certain vehicle speed and volume thresholds are met. The messages provide information on the traffic conditions, whether slow or stopped, and the distance the motorist is likely to encounter these conditions. Another frequently used Smart Work Zone strategy is Dynamic Lane Merge, or DLM. The DLM strategy is used for highway lane closures to increase the safety and reduce traffic delays. Typically, during a highway lane closure, there are some drivers who move over immediately once they see the first advisory sign, while other motorists will wait till the last possible moment before merging over to the open lane. This variability in the decisions and attitude of motorists results in traffic speed differentials, hard braking, road rage, and crashes. The DLM strategy is used to create more orderly merging conditions at lane closures based on traffic volumes and communicates guidance to drivers through PCMS or through connected vehicle onboard units. This strategy has two operational scenarios, dynamic early merge and dynamic late merge, also called the zipper merge. The dynamic lane merge early merge operation works best for low traffic volume conditions, where there are ample gaps in traffic to get all vehicles to merge into the open lanes early so that they are traveling at uniform speeds when they approach the lane closure. The DLM late merge strategy works best when approaching traffic volumes are nearing or exceeding the capacity of the remaining open lanes. Unlike early merge, where drivers are encouraged to move lanes as soon as possible, the late merge directs motorists to stay in their existing lanes and merge at a single point just prior to the lane closure. Then, motorists are directed to merge, or zipper, with other drivers by taking turns in an orderly fashion. Late merge has been shown to reduce crashes and delay for lane closures in high volume conditions. Smart Work Zone Central Processor uses data from the Smart Work Zone portable vehicle detectors to implement either early or late merge based on real-time traffic conditions and transitions between the two modes as traffic conditions change. The Smart Work Zone Central Processor posts the relevant messages to the Smart Work Zone PCMSs from a library of pre-approved messages. The next two slides will show possible Smart Work Zone PCMS messages for early and late merge scenarios. So this slide shows possible PCMS messages for the dynamic lane merge early merge scenario. The Smart Work Zone PCMS directs drivers to move to the open lanes early so that by the time they get to the lane closure, all traffic is merged and flowing at a uniform speed. This slide shows possible PCMS messages for the dynamic lane merge late merge scenario. The Smart Work Zone PCMS directs drivers to use all lanes until they get to the merge point. At the merge point, drivers are encouraged to take turns or zipper into the open lane or lanes. A zipper type merge has been attempted using only static signs, but directing drivers to merge late during low volume conditions may result in hazardous maneuvers at the merge point. As noted earlier, this operational scenario has been shown to reduce delay and reduce the overall length of queues resulting from the lane closure when high traffic volumes exist. A less commonly used but promising Smart Work Zone strategy is Dynamic Speed Harmonization, or DSH. DSH is intended to uniformly reduce speeds as traffic approaches area of traffic congestion, bottlenecks, incidents, special events, and other conditions that affect traffic flow. The DSH strategy assists in maintaining traffic flow by reducing unnecessary stops and starts and maintaining consistent speeds. The speed limits generated by the SWZ's central processor are displayed on Smart Work Zone portable variable speed limit signs and are sent to the WZDX to be available as onboard messages for connected vehicles. There are two common instances for using the DSH in work zones. The first instance is when traffic speeds vary through the work zone and or where traffic speed approaching the work zone is considerably higher than the speed through the work zone. The second instance is when lower speed limits are needed to protect workers who are close in proximity to passing traffic as compared to when they are protected by barriers. The Smart Work Zone central processor gathers approaching and through vehicle data for the work zone. Using predefined algorithms, the Smart Work Zone central processor calculates and sends regulatory speed limits to the portable variable speed limit signs, with the intent of gradually slowing traffic as it approaches the slowed traffic condition or bottleneck. Also, electronic speed feedback signs are used to reinforce to drivers the need to obey the speed limit. Further, off-duty law enforcement officers are also used to reinforce the speed limit even when they can't safely enforce a work zone speed limits. Lastly, Smart Work Zone PCMSs warn drivers of the speed reduction ahead. So the next slide is going to show a conceptual layout for the dynamic speed harmonization strategy. For this strategy, speed limits are determined by the Smart Work Zone central processor, again using the pre-approved scenarios for setting the maximum and minimum speed limits, and the incremental speed limit changes from VSL sign to VSL sign. The speed limits are based on current downstream traffic speeds. Smart Work Zone PCMS warn motorists the distance until the next reduction in speed that will be shown on a Smart Work Zone variable speed limit sign. FDOT's speed zoning manual requires speed limits to be approved by the district traffic operations engineer or delegate. Typically, this role will be delegated to an operator at the Regional Transportation Management Center who will review and accept the speed limits generated by the Smart Work Zone central processor through an internet-based interface with the system. An advantage of this strategy is that lower speed limits can be posted where workers are present, or allowing a higher speed limit where workers are not present and where lane restrictions allow a higher speed limit. So this slide here provides a very high-level overview of the typical benefits seen when using Smart Work Zone strategies. All the Smart Work Zone strategies are intended to improve safety and efficiency for traffic approaching and moving through work zones. These strategies also support increased safety for construction workers. Might need your help, Justin. Thank you. The FDOT Transportation System Management and Operations, TSMO, strategic plan identifies mainstreaming as a priority focus area for TSM&O, including Smart Work Zone implementation. FDOT uses guides, standards, manuals, and specifications to mainstream transportation practices and technologies. Altogether, these documents will lead to a consistent Smart Work Zone implementation. With consistent implementation, drivers will have greater awareness and recognition of Smart Work Zone strategies as they traverse work zones. Over the next few years, FDOT will gain additional familiarity with Smart Work Zones and continue to improve the standards, FDOT design manual, and specifications. The next group of slides summarize how the Smart Work Zone strategies and technologies are addressed in the guide document, developmental standard plans, developmental design criteria, and developmental specs. Go ahead, WD.
Thank you, James. If we can go to the next slide, please. So as James mentioned, we had 4 documents in particular that were developed to help communicate to designers and contractors what's needed for smart work zones. In order, it's the Smart Work Zone Design and Operations Guidebook, developmental standard plans, developmental design criteria for FDOT design manual, and then also some dev specs were put together particularly as well. I'll just give a high-level overview of some of these so you can become familiar with what we utilize to communicate to our designers and contractors. Next slide.
Oh, Justin, can you help us out? Thank you.
Thank you, Justin. So the Smart Work Zone Design and Operations Guidebook is really a layperson's instruction manual or document to help make you familiar with these technologies that James has described. It is filled with illustrations and just simple explanations to help understand what it is we're trying to do before you get to the point of actually being in detailed design or trying to implement in construction. So if you're looking at our particular technologies, I'd really encourage you to go take a look at this document first as a good high-level overview. It provides information on the programming and the scoping of these types of projects, and it talks in detail about the identification and selection of the Smart Work Zone strategies. Also, because it is ITS, it does require systems engineering analysis and touches on that. And then also in looking at how these types of technologies should be folded into the public information plan. Next slide. As mentioned before, the developmental design criteria is what is married into the design manual. We've updated the different sections there to include not just the standard work zone information, but it has the embedded information now about what do you do with the different types of smart work zone technologies. You see in there the speed harmonization, dynamic lane merge, and dynamic queue detection, all being part of the different types of strategies to help take care of different demands or needs that traffic can create in the work zones. Next slide. Developmental standard plans here serve as a kind of a template then for designers as they try and take a look at their specific work zone and say, how should we lay out these particular technologies or each element that's a part of this whole system. As James always wants me to emphasize, and I say it all the time to designers, this is just a guide. This just gives you an idea generally of how to place things, but the designers have to be responsible for layout of these and placing them in some sequence that meets their specific situations. And we have them for all three of the technologies described. Next slide. And of course, having the specifications we need. The first one, DevSpec 102, really talks about the pay items, how the systems work and function. And then the second part, DevSpec 990, really talks about each one of the specific elements that are in there, the VMSs, the variable speed limit signs, all of those in great detail, so that the designers and the contractors know what to bring to the field in implementing their systems. Next slide. Go ahead, James.
All right, thank you, WD. As you can see, our contact information is on the slide. If you guys have any questions for all of our FDOT Smart Work Zone developmental, give us a quick shout out. We'll be glad to answer any questions. And of course, FDOT, we have our safety message. Justin, could you go to the next slide for me? So work zone safety is everyone's job. Watch vehicles entering and leaving the roadway, beware of workers while driving through the work zone, follow the posted speed limit, and avoid distractions. Thank you, guys. Brad?
All right, let's jump to our next presenter. Dan, take it away.
All right, so yeah, I'm Dan Sprengler. I work at the Iowa DOT as a work zone traffic control engineer. I just want to touch on kind of a little bit of a history of where we've been with smarter work zones in Iowa, and it's a very high overview, and it's going to get into a little bit of the data you heard Skylar and Darcy talk about before too, because we're heavily involved in collecting data. So I'm going to talk a little bit about our Iowa Work Zone Data Hub. Just briefly touch on some of the connected devices we have, and then what we're doing with some of the data analysis. So the data hub actually started out when we started asking questions that we couldn't answer. You know, we didn't know how many lane closures we had in a construction year, and we didn't know actually the exact number of active work zones right now at this period of time. So all these types of questions, we feel we really need to have a better way to get at this than try to dig through field books and diaries and notes from the inspectors and things like that. So one of the guys here, and his name's Willie, and everybody knows Willie. Willie dreams big, and so he said we need a research grade work zone database to answer some of these questions. About the same time this was happening in 2014, we started identifying traffic critical projects on our routes that were likely to cause safety and mobility impacts when we were out there working. And kind of like anything that was high speed, or it's on a multi-lane and more than 15,000 vehicles per day on the roadway. That was our first sorting mechanism to go through. And so we would identify what these projects were and then what we could do by deploying all the different IWZ systems. Like end of queue is probably the biggest thing that we use right now, end of queue. We've done some things with advanced warning speeds, kind of a variable type thing coming into a project. But all this information that we're collecting now off the sensors and everything else, we're feeding that through the traffic management center. And so now it's available for our use. About the same time, the Work Zone Data Initiative started up. And so that WZDX was an opportunity for us to collect and share the data from Iowa work zones. And our plan was that we would use the data for designing and planning our traffic control, and also for real-time operations as we're out there when the traffic control is deployed, and then also looking at historical information for better analytics so that we could decide what we wanted to do in the future. Another tool that we've incorporated, we've got all these traffic sensors as far as automatic traffic recorders, we got ITS sensors, and any of the IWZ devices we deploy out there are capable of collecting information on traffic for us. So our goal was to take all this information and put into a graphical form where we could actually look at what we were expecting for hourly traffic. What this system does, it takes 24/7 counts and then massages it so that, and I'll show you here in a future slide, we're looking for allowable work times. So I would click on a sensor on our map, and this happens to be an ITS sensor, and it would bring up, this just happens to show the bar graph, every color for every hour. So you got 7 bars in here. So it's one for each day on this particular map that I have, from 12 o'clock midnight all the way through again till midnight. And so, and based on the type of work zone configuration that we chose, this happens to be just a lane closure, it will give me a threshold of the capacity that I can expect on there. So anything above that line for hourly traffic is going to cause me problems. So this is just a tool that we can use when we're planning and designing our traffic control. Now that got to be a little bit much for some of the designers and some of the districts. So we took that information and we condensed it into what we call district lane closure maps. And so those maps are color coded. This kind of shows the same stretch of roadway that I was looking at with the lane closure planning tool, and it will give the allowable hours based on the color and the time of day, what they can do, whether they can close a shoulder or they can close a lane, or some cases, if it's more than 3 lanes or something, they may be able to close a couple lanes. So this information that we're getting off these maps are what's going into the plan for the contractor. Now, a little bit about some of the connected devices. So I mentioned that all the IWZ devices we're putting out there are sending information to the Traffic Management Center. In addition to that, the aero boards, we're requiring connected boards for all of our lane closures in Iowa now. Next spring, we'll start deploying the portable traffic signals to collect information on location and operation. And then, of course, as the future devices come on board, AFADs will probably be the next thing, but the whole idea with our connected devices is started out with the aero board just because it was simple. Turn it on. The contractor had to do nothing else. And the problem we're having right now is we want to know where the end of the work zone is too. And so far, we haven't found a foolproof device to do that. Somebody's got to turn a switch someplace. So, but if anybody's got any good ideas, let me know. So like I said, all this information is going to the Traffic Management Center. The Traffic Management Center that we have is it's one location here just south of us in Ankeny, and they can watch everything that goes on, including the work zone devices that we put up for temporary use. They're connected into all that information, and they can use those devices to manage incidents that might happen, whether it be in the work zone or not. So they've got additional devices at their disposal for traffic management. I was talking about the aero board. So in 2019, we developed a protocol. We thought, why shouldn't we be able to identify where a lane is closed? And that was, it just seemed natural. Let's go for the aero board. And so we developed our own communication protocol for the aero boards. We worked with the manufacturers and the contractors to finalize that specification. And in 2021, we required that all lane closures on the interstate had to have the connected aero boards, and then we extended that into all lane closures in 2022. And like I said, right now we're using our own protocol. If anybody asks me for information about what we use for specifications for connected boards, I always throw them back to the WZDX protocol, just because it's more common. So eventually we'll switch over to that also. So right now, Iowa State University put together a map where we can actually see where all of the aero boards are in the state. And I can click on any one of these and it will show me what mode it's in. We use like sequential chevrons for our lane closures in Iowa. And then it will also show who owns the board and who's the manufacturer and the type of software it's running. So in fact, we've had contractors, they'll check on each other and make sure the other contractors' boards turned on, because they have access to this map too. The next thing we're looking at is connected portable traffic signals. Like I said, in 2025, that's when we're going to go into effect with that on projects. It's going to be a statewide deployment also. we started developing our own communication protocol, but then when WZDX decided to put a protocol out for work zone devices, we decided to hold off on that until that was finished so that we didn't have to redo that. Talk a little bit about data analysis. So you can imagine we're collecting vast amount of data with all these devices coming into the Traffic Management Center. The Institute for Transportation, INTRANS at Iowa State University, they're our key partner for organizing and keeping track of all our data. And Skylar, who was on earlier, he's the guy that I don't want to have get hit by a bus or something, because if he's gone, we're in trouble. Oops, excuse me. So with what they've done with some of the data analysis, they can generate daily and weekly reports of our connected work zones. And my advice to anybody who wants to try this data thing is to get a university partner, because they're the ones that are going to keep you moving. So here's some of the dashboards that Iowa State has put together. This is kind of their general page, splash page, but they've gone, and besides just work zones, they've done other intersection warning systems and all this kind of thing. The one that we use a lot in my area here is the work zone. So they've got different dashboards that we can tap into to look at how things are performing. One of the key ones is the traffic critical work zones, which are usually equipped with IWZ deployments. And so if I click on here, or I can choose right down the right side of what project I want to look at, it'll give me analysis of queue lengths and vehicles. And just this happens to be a weekly performance, but these can get sent out to usually to the districts and to the RCEs who are managing the projects, so they can see how their work zones are performing. And it also, here's a heat map, but there was nothing really exciting happening on the day that I captured this one. But these are the sensors along the left side here, and it's giving me a section of roadway and what's happening. And then these would be the hourly counts I expected throughout the day. And then besides just the connected devices that we have deployed, we can use probe data. I think Skylar talked about this a little bit. If you have an incident where you don't have any equipment set up and you had a problem, you can go back and analyze what went wrong, or how long the queue was, what the length of the queue was, things like that, duration, with just probe data. So that's kind of exciting. And then my biggest thing I like now is the connected vehicle data, like Skylar and Darcy were talking about, because we can actually go out and check for hard braking. And usually the hard braking means you probably got a congestion or something else going on in that work zone. And so a lot of different analysis that we can do with the connected vehicle data. And my favorite one is the one that Darcy showed before, which is the velocity lines here of each crash, because when there's a crash, you can see how the queue starts building up. And so if this is time and distance, this is speed. And so this tells you how fast that queue may be building and what extent it's going to interfere with traffic further upstream. I think this has a real potential for when you subscribe to live connected vehicle data to be able to detect incidents without ever deploying any IWZ equipment for like end of queue warning things. So that's what I think is really exciting. So kind of in summary there, when it comes to smarter work zones, I think one of the biggest things is to make use of multiple data sources. See what you don't just depend on one, but use whatever is at your disposal. And then make sure the data is available to your field operations staff so that they can manage the work zones that are deployed. And then the designers need it so that they can do a better job of designing work zones and staging and get a better idea of costs of the project. So a lot of times what we'll do is before we ever get done with the concept, we're looking at the data and the traffic to get a better idea of what it may cost for us to deploy some of these intelligent work zone systems, because it's going to change the cost of your project. So the sooner you know that, the better. And then it's important to have that historical data so that your management can, or you can use it to inform your management to make better overall work zone strategy decisions. One thing I was going to mention too, and I didn't, was that when it comes to like the IWZ deployments that we put out for our work zones, we have a single statewide contract that we make use of for all the different projects. So we don't do it project by project. It's not up to the general contractor who's bidding the project, but we have a separate contract, and it really makes things flexible, and we're not afraid to spend a lot of money on a small project. You know, usually think, well, that IWZ is going to cost more than the project, but when you have the statewide contract, it makes it a lot more flexible, and so I think the cost gets spread around a little bit better. That's all I've got. I'll give it to Neil.
All right, thank you, Dan. Good afternoon, everyone. Once again, my name is Neil Boudreau from Mass DOT. I'll give you an overview of smart work zones in Mass. It kind of culminates a lot of what you heard already today into our program. And then I'll focus a little bit on our device connectivity and improving the accuracy of our data feed. If I can get this to, I can't get the slide to advance. Nope, hold on. There we go. All right, so the first slide I'm going to cover, oops, I skipped my agenda. Smart work zone practices, I'll cover those first. A little bit about what you saw from Florida, from James. Then I'll go into our connected work zone notification system, and then close it out with our work zone manager, talk about our lane closure requests and how we're validating the data. So first time we'll start with real-time traffic management. So smart work zone practices in Massachusetts have long been established. We've been putting them out for a number of years, and it's now been institutionalized into our program. Our design engineers and our project development folks kind of know what to do. They know to follow the process. We do have a scoring matrix, which helps to evaluate the need for smart work zones. So I would like to say that it's a smooth operation. There are times where I wish that the designers would actually talk more to my section, but for the most part, we make sure everything works well. And one of the key things is on the construction side of the house, making sure that the vendors and the contractors demonstrate that experience so that they can meet the specifications for the job. SDOT specifications, they've been fairly consistent for at least 10 years. We've only done a few minor updates. They are rather lengthy. I have received a few comments from some of the vendors about how much details we have in there. So we're in the process, like Florida and a few other states I'm aware of, that are streamlining the actual specifications, try to lessen the burden on the vendor. We eliminated some of the qualifications package requirements, especially where the vendors have been doing work with us. We don't need to re-see everything from them. We added some language in recent years about the API data feed because we've been WZDX feed state for a number of years. And we've also lightened up, we used to be really focused on all sensors in our work zones. We're now using a lot of probe data. We still do like to have sensors out to get some of the speed, volume, and occupancy information, particularly through the work area. So our change is focusing more on, again, like Florida showed you earlier, is making like a plug and play type system where you'd have the option of a basic travel time system, a back of queue system, which also includes travel time, and then the Cadillac, which is the dynamic merge system, which also includes back of queue and travel time. And then also introducing individual pay items. So you'd have a pay items for the different types of equipment that are needed to put these systems out. And then for the overall system that is needed to run the background operations, the algorithms. And it's also part of this new update where improving the guidance that we give to the design engineer on what's required for the plan specifications and estimates. So this is a snapshot of a draft that we have working, which shows a typical layout and message logic for basic travel time systems. So you have your one roadway type system where you're only giving travel times along the route where you're actually doing the work versus a multiple route or two route system. We've been using this more frequently where we have an alternate route and we have travel times for both routes, so it gives the motorist the option to stay on the route where the work is happening or to divert and take that alternate route. We don't have a lot of alternate route opportunities in Massachusetts. We just weren't built like some of the more, I guess we'll call them the younger states where you have parallel freeways and whatnot. So it's usually a crapshoot for us, but we have tried this from time to time. Next, this is kind of an overview of our backup queue warning system. Again, the whole goal here is to show the designer so that they can understand better the placement of the portable changeable message signs, where we require sensors and whatnot, and the logic behind it in terms of how they would lay it out. So you can take this typical and then apply it to your specific project so that you're placing the devices on the roadway for your plan set for the contractor to be able to bid. And then, obviously it's hard to kind of see on the right-hand side. I squished it down, but that's basically the logic in terms of what those sensors are picking up and when we're changing the message to give the best advice to the motorist. I thought the graphics that James used were far nicer than mine, so compliments to Florida DOT. And then here we have our dynamic merge system. Again, same concept. You have a typical layout. You have the logic with the speed threshold. So when we drop below certain speed criteria, when do you convert to the messaging so that you're giving the driver that's approaching the scene the best information possible to help them navigate through the work area and try to maximize that efficiency so your operations don't degrade. In Massachusetts, our drivers don't always play nice. The concept of the friendly merge is usually not used. So we actually do find that putting a sign and telling them what to do has been helpful. So it's definitely an opportunity for us to continue to do this. And again, the image on the right is just, again, the graphical depiction of the logic in terms of the different placements of the sensors and the message boards to help trigger those changes. So now a little bit about our connected work zone notification system, and yes, that is definitely a mouthful when you, I don't know, hopefully our designers and our people in our field offices and construction will start to understand the CWZNS. Or we have to come up with a more creative name. But so we're currently working on developing new specifications for this. We're about 90% completed. I think the real meat of the specification is completed. The last component, which we've been stuck on for quite a while, is just been the final agreement on the pay items, because we are introducing new items and we have a specifications committee that we have to kind of work through, as well as penalties. If the contractor puts out equipment that's not working and is not performing, we obviously want to be able to deduct some of the daily pays that we're paying for. So that's where we're stuck. But the system itself consists of the start and end markers. We want to digitally mark those points of the work zone. A connected arrow board or multiple arrow boards that would all be connected just to give that information about what's happening. The dynamic work zone speed limit assembly. Again, that's another long term that we need to kind of shorten, but that's basically just displaying what the speed limit on a hybrid speed limit sign, so that we can understand, when we do reduce the speed, we're tracking when and where that is being happening for, in case there is a crash and we need to provide data to the law enforcement folks. And then, once we've established, as people are entering that work zone, that we've reduced the speed limit, we want to use, 1, 2, or multiple throughout the work zone feedback assemblies, where we are continuing to remind people about the speed limit, but also giving them that feedback so that they can hopefully see that they're compliant and paying attention. So that's the nuts and bolts to our dynamic or connected work zone system. I know this is kind of a funny graphic. I showed it before in a presentation at another meeting, but there are a number of different manufacturers that make either digital speed limit signs and radar feedback signs, you know, on trailers in different configurations, in an effort to try not to specify one vendor over the other, but also try to maintain some consistency with what the Manual on Uniform Traffic Control Devices requires. We put together some guidelines as to what we would like to see out there to try to help the contractors at least choose something that you know, keeps us somewhat in compliance. So this will be part of what we provide to contractors and designers. And then this is just one example of a typical application of putting the connected work zone notification system in place. So you've got all the other traditional static signs. You know, in Massachusetts, we have the work zone speeding fines are doubled, so we've got to add that into the mix. So there's, oops, I don't know why my slide just moved, but so, you know, trying to provide the contractor, you know, the field technicians, you know, with some degree of explanation of what they need to put out and where, so that they understand that. We want this to work when we put this in the specification to deploy it. So therefore, you know, I'm sure this will take a while for us to get up and running, but and get it to run perfectly. Okay, here's our work zone manager. It's going to be our next item. So for a number of years, we started the development of a web-based, user-friendly application to kind of track our work zones. The whole goal started initially with me because we had a number of smart work zones out there and we had several different vendors. Our contractors, I mean, our construction folks were complaining that they had to learn too many different systems. So we first set out to build something that we could make as an overlay to best cover all the different work zone, smart work zone companies out there. So we are all on one uniform platform. Once the WZDX efforts was initiated, we kind of stopped production on that, pulled back, and then we started to pull in the planned work zones. And now we've come a long way with the work zone manager tool. Is it allows us to configure, manage, and monitor all those planned work zones. We can also see where all the portable field devices are for whether it's a smart work zone or connected. We allow it to some reporting of work zones and historical data. I know Dan mentioned this, how the importance of knowing what you have out on the roadway and where. We can integrate with planned events. So we know that if there is a planned event and we're trying to do a lane closure or something like that, where the conflicts are, we are, you know, one of the keys was to develop the automated validation. So when we have planned events and then we actually have devices out there to basically associate them so that we can validate that they're actually happening. And obviously publishing the work zone data feed that we have been requiring from all devices, as well as you know, our planned events. We're pushing that out. What's new in the last year is we started developing a new modernized lane closure request tool. We used to have a very antiquated system. So the goal is to improve the quality of planned work zone data. The tool is built 100% based on the concepts of WZDX, the terminology, and it was configured to be user-friendly so that the resident engineer, the construction inspector, whoever could put in that request to do the lane closure. The information they're capturing will basically, you know, be in a format that makes it easy for WZDX, but also for the end user. It's configured so that we can, again, do the automatic validation of different closure restrictions. So we have time of day, you know, how many lanes you can close based on time of day, how close you can be to an adjacent work zone, those type of things. Those warnings are built in. And the goal is to make sure that we're cognizant of all the work that's going on and to prevent conflict points. So part of that is the approval process. So right now we rolled out this pilot with one of our districts that happened throughout the 2024 construction season, and the goal is to allow the district staff to review the requests that come in from all the different construction projects. So they have dedicated staff in their operations group that review them, look for those conflicts, looks to make sure that they're following time of day restrictions and whatnot, and then approve that lane closure. So there is a process. If there's something missing, if there's data that's not provided, it can kick it back to the field office to get more information, or if there's a conflict. But we have a formalized process to approve that, so that helps us so we know what's going on. Again, there's warnings, and one of the new things that we built in at the same time we were working on this is we have a project with Kittleson Associates to build like a lane closure impact tool that's based on our volume network. So we have permanent count stations out there, so we're pulling in that annual count data. So and then we're evaluating using capacity ratio, volume to capacity ratios of how much volume is on that roadway, based on the number of lanes, and when can we close the highway. So some roadways we might be able to start work at 7 o'clock. When you get closer to our busier urban areas, we might not start till 10 or 11 o'clock, and that's all based on the volumes using that roadway. So this is built into that volume profile tool, and Kittleson has established the hours that you can close, how many lanes on each particular roadway. That's being imported into the tool that Arcadis, the Work Zone Manager tool. So now that's all going to be automated. So if a resident engineer wants to close a lane for a project at 8 o'clock and the volume and capacity ratio won't allow that till 10 o'clock, he's going to get that warning. It's going to get kicked back. So that's one of the new features that we just added in. And then this is kind of bringing it all together. So, we now have better quality information with the requests that are coming in. We have the goal of getting the connected work zone notification system specification into all of our freeway and interstate work, so that we're digitally mapping all of those locations. So the goal will be is we have high quality planned information, then we have devices deployed out in the field that when activated will validate that that is a true and active work zone, so that we'll be able to better track when those things are happening. So again, this is just showing an example of a start and end marker, an arrow board. It shows how it's connecting to our Work Zone Manager tool, and it's also being fed to Waze. And Waze is pushing that information so that the driver is seeing really detailed specifics about where the work zone starts, the operation of the arrow board, and then where the work zone ends. And that's with that automated association. We just rolled that out 2 weeks ago. So. And then last, we did submit for a SMART grant earlier this year. We spent a lot of state money developing this. In fact, we used a US DOT grant to develop the device feed, to kind of standardize all the different devices that are used in smart and connected work zones. Recognizing the importance of that throughout the country is having one standard language. I think Dan mentioned that specifically, is why have different states with different requirements? Let's all use the same language. So the next grant is to continue the advancement of the tool, enhancing the data capture, and building in performance metrics. So we're capturing data, but we really haven't done a lot with the operational performance metrics. So that's the next step. And we want to harmonize all the data from different sources. There's some other information that we can pull in that we think will be beneficial to reporting on work zones. And the key here is it's all about situational awareness. If we can provide our public, either through our Mass 511 site or through the mapping providers, or even onboard connected units, the more information we can provide to the motorists, the better and safer we'll be in the work zone. And That's it. Thank you. So now I guess we can open up to questions for everyone.
Thanks so much, Neil, and all the panelists. We do have a few questions and a few minutes as we wrap up the session for the day. So if our others could join us. And so to begin with, does the Florida DOT have a smart work zone need assessment criteria like the scoring matrix used by the Massachusetts DOT?
No, I don't think so. WD, do you? We don't have that yet, do we? We're still pretty developmental stage.
Would agree.
Yes, with FDOT, we're still in our developmental, so we're using a lot of pilot projects, testing our strategies, and then we're going to collect feedback from those, how they worked, and develop refinement from there.
So you can have it. It was developed actually by Federal Highway, TTI developed it. So there's a template. What we did is we took the template and we customized it for the operating conditions in Massachusetts. So they're far different than what Dan has in Iowa with the volume and traffic. So we customized our, and it's just an Excel spreadsheet. So you're more than welcome to take it and modify it. I think a couple other states have already done that.
Perfect.
Great. Next question, for states using dynamic zipper merge systems, are you using them just on 2-to-1 lane closures, or are you also using them on 3-to-2 lane closures?
So Dan, you want to go first, or? Oh, you're on mute, bud.
No, I mean, we don't really use dynamic lane merge systems in Iowa. So we've got some permanent ones, but that's about it. So, but yeah, I've never heard of them going from I mean, the only thing I've seen them on or tried them on, we did with two lanes to one. That's all I've been experienced with.
So in Mass, we don't have hardly any 2-to-2 lane freeways or interstates. So all of ours have been on either 4-lane roadways where we're dropping either 1 lane or 2 lanes or 3-lane facilities. So and again, because our driver behavior is less than stellar, I'll just put it nicely, we have found that they have been effective. And I think it's just giving that direction back to the motorists. Not everyone follows it, but it's helpful.
Great.
Yep.
Okay, someone else have some other comment? All right, let's move on to our next question. How are you determining that construction is actively underway? What data sets are you relying on to reflect that these work zones should be active?
I think one thing we're doing is trying to get those connected devices put out there. So when it's active, we know if the arrow board's on, it's probably an active work zone. When I get the signals connected, I know it's an active work zone. And so and what I mean by that, there's a restriction for traffic. Right. Okay, so it doesn't mean that maybe there's actual work going on at that period, but there is a restriction in traffic. So, and eventually the worker presence will get incorporated into that too.
Yeah. That's what I was going to mention, is that that's our next thing, is to start experimenting with the worker presence. The whole goal is, especially with a drop in the speed limit, is I want to get away from just putting a static sign up and people not paying attention because it's out there 24/7, and having that speed limit drop only when there's active work. It's one thing if you have geometric safety conditions, you have to drop it on a full-time basis, but when you've got men and women working, we want to basically draw attention to get compliance. So that's the keys.
Good. So next question, what's the status of the MassDOT Smart Grant on performance metrics? When does that end? When are you going to have some?
I don't know. I have to ask Martha if we're ever going to get it approved. It's been in for quite a while.
That was Jawad asking the question. So yeah. All right.
We're hopeful.
Good. Well, each of you, if you were being a little bit futurist here, where do you see us 5 years from now with some of this smart work zone technology? What do you think the potential is for reducing, impacts, crashes, fatalities in work zones? Where do you see us going from here? Maybe Neil, we'll start with you, and then we'll go to Dan and James and WD.
So my goal is to get into the vehicle without having to go through a phone. So, I mean, it's one thing, there's a lot of the generation that uses a smart, like an app for mapping services, but I want to get into the vehicle directly, automatically. We're already seeing that capability with commercial vehicles, with being able to get messages through their ELD units. I want that in every passenger car, because I think information is powerful. So.
Yeah. I think I'm aware of a couple of companies who've now adopted that. We can get it directed to the cars, but not all. Okay, Dan.
Well, the one thing, and this is a really specific thing, is so I have a Subaru Outback and it's got the adaptive cruise, and I love that because it'll follow the car in front of me. But I would really like to be able to control headways in work zones with connected vehicles, talking to each other, so that we're all going through at the same speed. And a lot of times that's going to take care of a lot of rear end crashes and things like that, and give a lot more control. I don't know how far away we are from that, but my car kind of does it, and it doesn't talk to anybody else about it. But I think that could be a really powerful situation, and actually maybe set the speed. What is the speed going to be of the work zone? Well, we'll tell you what you should be driving. So,
James?
Yeah, I agree with everyone. With as far as FDOT's concerned, in the next 5 years, hopefully with these pilot projects, we get good tangible data, and we can adjust our standards and specs based on that to help them to perform better and more efficiently. With the smart work zone technology, it's definitely going to, like Neil said, create that awareness within the vehicle and help drivers understand what's coming ahead and how they can be proactive and getting in the right position and helping that throughput for the work zone in the future.
All right, wrap us up, WD. We're a little over time, but we want to hear from you.
Just want to say about, it really comes down to the workers. We want the drivers and motorists and the families and everyone traveling through the work zones to be safe, but the exposed people out there are the workers. And I think that just with technology, with what we have, either to help is there's, a presence of workers closer to the roadway or in proximity, kind of dovetailing on what Dan was talking about. It's like using that to maybe adapt to the speeds of vehicles or adjust headways or things like that. Or getting back to Neil's point, letting the motorists know, hey, there's workers present here, maybe help call that to their attention some way. But just ultimately, we've got the technology out there. Let's do a little bit more if we can to keep the workers safe.
Excellent. Well, thank you, gentlemen, for participating with us. Very informative and just kind of exciting about what's happening. Things that many of us have looked forward to for many years that are starting to become a reality. And so thank you. Matt, why don't you wrap us up?
Sure. Thank you all for sticking with us today. I think this has been a really great panoply of wonderful sessions, and I personally really enjoyed them. Tomorrow we're going to meet back and do it all over again at 12:30 p.m. So we look forward to seeing you then. And for now, you guys have a great night.
Thank you.